only used in the aerospace industry, not only in the machine part. Now there are a lot of semiconductor design also application in the aerospace. Coming to the automotive side, automotive is a huge and vast examples. Almost all manufacturing now only started adapting the AM techniques. The prototype earlier they go for the mass production. Okay. So now they are saying before going for the mass production, they need the prototype. So we dealt with a lot of prototypes for AVD leather. So AVD leathers, they want to use the shoe and it doesn't consumer goods. Then wheels are manufactured. Disability equality. You see, the chair will not be a common for the disabled person. Okay. Each and every person have a different disability. Okay. So for everyone, based upon their disability pattern, the wheelchair is designed. Okay. So you see that there are some places where the wheels are getting unidirectional, bidirectional, and four-directional use. These wheels are getting printed at our import facilities. So, Chennai-based wheelchair manufacturers mainly uses new prototype. They will come, they will get printed at our facilities. That is one the wheelchair sector. Now the automotive part, it says BMW's Roadster, convertible top picture they are using. Then Volkswagen employs the serial production of the tools they are using. And of course, you could see this manufacturing of jigs, pictures, custom tooling, and spare parts on the demand. So, these custom jigs and pictures will enhance the production efficiency and also the on-demand spare parts reduce the entire inventory cost. Okay, sir. This is a wide application on the industry and the aerospace. So, any doubt you have clarified, you just let us know, and we will give more examples of the automotive segment is improving on this area. Yes, sir. Printed prototype. Sports person are wearing the shoes, no? So the shoes are model now getting printed using the
The shoe using
regularly they have seen people. All cricket persons using the curved type shoes.
Leather shoes.
The leather material but thermoplastics TPU material. So on the TPU material shoes, like they are making the shoes out of TPU material, and you can able to do it with that. With this FFF now you can do it. Like Crocs, recently Crocs kind of slippers are getting famous. So these things also is possible to be printed in the
materials are thermoplastic materials.
Thermoset also is possible because when you add polyurethane, like high content of polyurethane material into it, like you get the flexibility. As like we have one resin here, so which is a standard resin. So same way you get a flexible resin. When you are trying to make some components using flexible, like you can make shoes also.
We are going like this.
It may possibly in future using leather as
Maybe so, like kind of sheet lamination technique they might use it, but not in a leather. It's being not used exactly. But some compositions of that.
So again, you can see the next slide. Before that itself, you are they have used the technology called 4D midsole digital flex synthesis and midsole activities. And now the FMCG part, that's why you design this part of it. Top part of the we call it midsole. They are using the DS printing. Top is here only the features they are when they move or when they jump based upon their which type of sport they are involved in. I think now they are using some swimming also or easy float. They are using wings like thing they are using for quick movement inside the water current. So that's one model they are using. very big lens corporation. Iver knew whatever the design you want to the like Rajini comes with one more glass and above one more glass he will make. So all this type of Ivers are all getting printed using this So the consumer side is a very big boom, and these are all act as a say for one Adidas will not manufacture. He will ask all these entrepreneurs to do that and supply to the industry. Branding only Adidas will do. That's why I'm saying entrepreneurship development is a very big boom of this. A small company now. Since you are also there, the government is giving a lot of subsidies on the startups, the innovation side. So the innovation side, if you want to do on there are separate divisions and all that. In that they will put a different research. Once that prototype is used, 3D printing machine, getting one machine, from the funding itself, the person. So a lot of innovation council. So training part and also the innovation we will give the hands-on experience using the mentor training factors. From there you can set up the lab. So this is one entrepreneurship program. So this is only healthcare and consumer. So 3D printing in medical application, I think we have doctors cleared about from Gera also. So custom prosthetics and implants. Fashion specific designs improve the fit and function, non-technical precision for outcomes. Surgical planning models we can use. Then bioprinting advancements and rapid prototyping. These are activities we are doing. Now we have seen live examples of the doctors using. So I got surgery using the 3D printing. 3 plates they placed for me. Okay, in a 22 I met with accident. One doctor suggested for only 2 plates, but they say they packed this thing will not support for you because you are in ankle surgery. So the thing is that immediately within 2 days they got printed. Earlier what they used to do, they will keep by the rod and check whether the rod is fitting or not. Then after fitting, you might have many people hearing saying that sir. Rod which it is not coming out, the rods are getting, the screw is coming out. Now they are made very printed. I did it Sundar Medical only. So within I have to wait for 3 days only. Normally they told Thursday, Monday you have something like that. 3 days only they made all these 3 plates using on the common thing they came. Otherwise no one side one plate, another side 3 plates is sufficient. Now complete movement I am having. Likewise all they are moving normal all movements at I went for jogging. I completed marathon 5 km itself. 23 is so that way they are now practically designed. This is very small. Now complex surgeries are get many hospitals. So hip replacement, Dr. Ella, they are all using a lot of implants. Next slide I can see. So this is our because it is medical implant use cases. The humerus implant, you see the fractured plate, then extended acetoplasm implant, cranial implant, then you have spacers, and this cells, I told you, screw and all, like this they are making very easy so that it will be very easy, it will not be screw type only. That curing process also very quick. Within so after post surgery, some people curing time will be very 3 months or something. Now within 30 days it is getting cured and no one knows the screw is available or not. Such a type of printing they are using this area. Screw irukadhu theriyala. So cranial implant, dental and chain, very huge. Simple now using our resin printing what we can do is then tooth scanning, they are doing that one. After this tooth scanning, immediately they take the print and then keep it. Tooth C, immersive engineer, these are all the players who is using the 3D printing technology. So my invitation to college is as center, we can act as a shop for the nearest village so that they can come and they don't need to ask the patient to wait for some time or go to make some mold, take their appointment. Now it's very easy. Brush kind of thing they are inserting. It will entirely take the picture, put it in the system, print system, then automatically it gets printed and it will go out. So the page replacement is also. So medical side, there are a lot of AM applications are there. So I'm saying futuristic frontiers beyond traditional AM. So what are all the changes? As I said, is mass customization. The tailored product for the individual customers. Personalized goods become to the normal. So we don't need to say whatever the things available with that FMCG, we don't need to ask them, I want FMCG. They say what you want, you tell us. Fashion industry, designers, very big way. I want like this. Recently we visited the internship for the School of Design. It's in Chennai. You don't believe students are doing a lot of design sectors. Even they are competing with engineering students. The chair is they developed a very different model. In our old stage, we say our grandfather used to rest in some cross table cloth and all. Cloth is that. We call it communist. We call it. Now these students design the same type of chairs. So all this thing, flexibilities, everything they are doing. So one easy chair kind of thing they are making that. That's one design. They are doing perfection. Whenever you want, based upon your need, they are designer. And chairs, they are using a cardboard based design, okay, and getting printed. And it is very customizable. So the moment you can make this type and you can make this vertical and horizontal. So like this, they are doing a lot of design activities. Actually, mass customization is very important on this traditional. Then the integrated functions. As I said, this mechanical part is tightly integrated to the other engineering machines, like printing electronics and sensors, they are taking the parts. Then second, smart products also from the door. So these two activities jointly integrated functionality helps the engineering product also study also. Coming to the multi-material printing, where they are combining diverse material finance property, where they integrate the hybrid and the high performance components. This is, as I said, every world is moving towards the sustainable goals. Okay, for achievement of the SDG, this is a very aesthetic method, AM printing. So where you can eco-friendly and efficient process of things are getting printed using this. So this feature contents beyond the normal traditional area. So as an institution, so I would recommend you to put your students on this process. So then they will see on the ESG part they can recover. One good example I can able to say that recently one government project came to us to clean the water lotus in the pond. So there they are not able to see how you can clean. So there are water like how we are using the bulldozer for axing down and then clean the water and all. There is some water thing which is getting heated, but still it can't be able to cover the entire the lake area or the so what one startup did is they used really drone technology. This drone parts is getting printed using green. Okay, so how they did is they projected the mother drone from the child drone. Okay, so if you use mother drone, it will go with one angle, make it square or make it round like that only it will come. So it can't be able to clean the side where it's a very, again it's a failure. It happened. So what we suggested now in you put the mother drone up from there project the 4 child drones. The mother also will suck it out and this child drone also it's like so these child parts are getting printed using 3D axis, small axis. From that it will be getting observed. So that way actually it became a very sustainable project. This is implemented because in Kerala they recently launched this water. There they need to clear this water bodies regularly for that to be and two innovation team has managed. But still, lot of R&D is there. Challenges is also there. Again, the water bodies immediately we talk about Kerala rains come, it will again pull all the. So I suggest you to students to think on those angles for their projects. So next, the advancement is on the exploring the 4D printing. So materials that transform. So 3D plus another will come. So 3D, 4D, it means 3 objects over the layer we can do that. The shape memory polymers, hydrogels, and acidics we can do. So here the application ranging from your self-assembling structures to the adaptive biomedical devices, and you can make on the soft robotics also. So a lot of biomedical applications are going to getting 4D. So this is again advancement of application to the 4D. So as I said, since I am coming in the academic side, so what this aim in education institution is for the innovation students. They can get the hands-on experience of rapid prototyping for projects, and they can enable the iterative design cycles and support the STEM education. I think Wipro has launched the program for even school levels. Aim design thinking lab. They have set up the design thinking lab for the school level KX standards. So research scholars, as I said, for the accelerating material science and the new process development, and you can do the testing novel material and composite printing parameters very quickly. So this is for the almost all the research scholars, say professors, all of those they are sitting here. So you can make utilize on the cutting-edge research, curriculum development, and you can establish a dedicated AM lab and training for the future. So these are your responsibilities on the education institutions for the post-secondary. So these are places where already the aims are in place, like IT Bombay, where they are using the batic type of AM components. Then VIT Vellore, again Wipro, strong partner with almost of a DP on VIT Vellore. So advanced manufacturing lab and students using for the drone components. Then IIC Bangalore, NITs and all IITs. So they are saying now our focus for the past 2 years on Wipro is go to the tier 2 and tier 3 institutions. So earlier the top tier institutions we want to do all these subjects. There are cases which we went to the tier 2 city, sir, we are going to set up the Additive. They immediately will say, sir, we are not a big college or we are not a big institution. We break that mindset. Those help on other things, they are also ready to come to the second, tier 2, tier 3 colleges, where this kind of innovation should reach the down to earth people. That's why even you can see a lot of government schemes also startup across all states. In Karnataka also they are bringing a lot of innovation. Each city they are bringing the innovation along with the college. Each city. In Tamil Nadu, we are having 7 regional hubs. These all 7 regional hubs of startup will function with all these 7 metro cities and also aligned with the downside cities. If it is taking Chennai, nearby 4 districts will be covered by the innovation. So same thing in Karnataka also. They are planning Kerala, AP. So all states almost they are planning this kind of. Sir, Government of India's scheme is Skill India. So there they are already floated on this store. Using that Skill India, they started the Startup India project. No, Startup India is Indian government. Each and every state then started their own startup. Like Andhra, they are having a teacup, Telangana. Then AP also they are having Karnataka is Invest Karnataka and Innovation Karnataka. So Tamil Nadu is startup team, Kerala is Kerala startup mission, like Assam also Northeast Frontier Innovation Mission, Mumbai also Maha Mumbai Innovation Council. So like this, each and every state they created the number and we reach out to the all. That's why I'm saying this pottery level it has reached. Okay. Rajasthan level, the pottery printing and all they are using Rajasthan, this right, those areas and all they are doing. Still it has to go through. But for that, who is the backbone students? Students who is finding again educational institutions. So that is why this program normally happen like this. The ATAL FDP plan is more of institution, industry and academia. These three people can only join hands to do the through these people. The top-notch layer also they don't say any colleges still lot of small here Telangana is one more very big institution launching. KLE also same. So they are institutions we don't believe that Telangana has such an innovation center. And in AP also here Nellore and all there is one college. They have such innovation center. The nearby rural people they are trying in Bangalore. So it's not only major cities now. They have got actually like institutions need help us. Then in fact, for case studies, as I say, we are saying it's ISRO. So I again improve the program for ISRO in getting the rocket plants and all. So component 80% reduce the weight of the specific parts. Auto devices also. I am saying surgical side, patient specific geometry activity, construction. It's a very big group. So the civil once again will boom back. The students are skilled with the AM technology. But every college is cutting up the civil engineering and mechanical engineering. Luckily, I'm glad to hear from sir, you cut off electrical, not mechanical. Many colleges we went to Andhra, no mechanical. No mechanical in Andhra. Full IT, ADS, ML, all this ML also they are if you go all computer related and all drilled down also specification in cyber security, cyber systems. What is it? Last week we went to SR. Under computer science, 10 branches are there.
Now they become a cluster, but
Cluster for it.
no, the government itself they are saying this is a cluster department. Don't say it is a separate department.
One of the guy came from that. They say, see, what are sir? Don't tell me computer science. I am from ADS, cyber security. Again, you are
cyber security.
Andhra, almost vanished all the mechanical. That's why we most giving a highlight touch to every institution wherever we go. The industry interact with the machines and also your coding. So we are not against the software. We are also a part of software company. We are running
Because they have to apply something in one physical experiments on this system. Mechanical.
automation happens.
All manufacturing companies they are facing a lot of problems. They don't have manpower. Whatever it is, they know inbuilt automation, but they need that manpower. They are not ready to.
No, rightly said. I said one more good example for this one. Kajaria ceramics we went in Andhra. As he said, they don't have manpower. The tiles are getting manufactured. It is coming. Okay, there is no. They reduced the manpower. Okay, what happened? They used the CVT technology. Okay, robotics, CVT, all these things are going on. It is passing all the tiles. Without any QC. See, QC means what they did is they are given one program to CVT stating that the corner level, if you find any damage, then you stop. Otherwise, you pass all these things. Like that, they written some programming languages is that using giving command to the ML using the CVT technology. And the machine also performs the same thing. Earlier, what we used to do, there will be one guy, whenever a guy come, he will show it to the heat and then every surface he will touch and see what is happening on this thing, then only he will come. This he came, when we went for CA, he said, this is the problem, sir. We will tell that you need manpower also, sir. Give train to manpower so that he will use this system very quickly. When he comes, then he deployed it to people and he is very happy. When he goes.
Putting black working, the final touch up of that painting, that will be done with the
Manually, no. Like, now they used some other one more use case, IR 4.2, using that, we went to Mundai. Okay, they are using the painting. Training they are doing using the wearable technology, they are using that one. Okay, you done painting, but how it manually do when you got the spriller, which is design is not proper. Mechanical design is which is done for sprillers not proper. The painting is patch, it is coming. But again, that has to be done by a human. So it has to human will value that along with the machine. Yes, both are synchronized. That is why IR 5.0 is coming. So combining this one, so IR 4.0 deals with only machines, automation, which now world says, okay, no need for IR 4, go for IR 5, connect with the human once again, and the coming with the environmental activity. So construction, as he said, in Chennai itself, 70 bus shelters, they are using 3D printing. They are going to launch in some time. All bus shelters, concrete structure. Sir, it is there in already. Chennai is very late, sir. Bangalore and all, they implemented.
Post office.
Post office is in Bangalore. Bus stop, Gujarat bus stop, and in Chennai is a bit later, but they will implement 70 shelters they went ready. So that's again the construction is very big industry. So as he said, like future is additive, come to action. So making in the initiative we have to do. That's why wherever we go, we will talk on Wipro who is doing this in the making India project. All 3D printers which are used are in China, or some other machines only. They have less materials only used.
Now, also we are using China model.
Try to make use of this Make in India project. We will encourage more Make in India. Sir, don't compromise on the cost amount. The brand values speak.
No, we compete with China based on the.
Yeah, right, sir. I went to Shenzhen. Whatever you want, they will make the iPhone in half an hour. Actually, you go for a street, you walk and then come back. They print and give the same iPhone. China, that's one side is different. But again, our lot of this secrecy are getting bigger. So we be more encouraged on the Make in India projects. Again, many people say Make in India test that is also Make in India also see this. Thank you, sir. Thank you once again. Hope I had conveyed
HTML file from Tamil sir today. So when I was trying to get it for printing, I noticed some errors. So I just thought let us have it as a discussion. Okay. So whenever I told you we use Materialize Magic software. Okay, it was ready for fixing some of the STL based errors. So that's what I could able to notice here also. So sir has created the image to 3D model software to create a 3D model. But what happens in this STL file is some of the triangles might be twisted. So on the back side, if you could see, these has become a hollow thing. Okay. So we have whenever we get some 3D models in the form of STL, there might be a chance of this triangle missing, or the triangles might be inverted. So because of that, During printing also you will face lot of issues. The printing failure can happen. So that one we have to check it with softwares like this and rectify it. Like in this kind of scenarios, we have to do it in a artistical way to like cover up this place. But I will show you like simple steps in the software, but that will not like properly fix the part. That's the auto fix option. It is not going to give the as texture as like this one, but it will try to cover up the face. So now we can like export this file and get it for 3D.
You can show them how to
So that sir
A2, sir.
I will share that.
You cannot extend to 3D model. Image
Yes, yes.
Same thing.
How can we convert that solids in
If you are used to image, software will give you the
Actually, software photo only.
Okay.
Yes. Yes, sir. Software photo. Can make 3D model. We see, I will share the.
this file I am trying to export and then we'll use it for printing purpose. Okay, I'll continue with my regular session. So we will start with some of the real-time case studies that have happened in Revolutionize. So that's what like we are going to discuss in detail. This might be mostly having metal printed components, and later like we will get into some of the polymer printed components also. First thing, certified parts by recovery. This means not all the components that we print is going to be like a productionized part. In the first day, I have told you about digital inventory. There we have seen like 4 different steps, like part selection, process transitions, then qualification, after that productionization. So this means we are already having some components which is ready for productionization. That means it's already in production stage. Whenever the company requires some component, immediately, that means these designs are already available in our digital inventory. So immediately you can go for printing. The first one is the inner ring component. So there is a component which comes with the Chetak helicopter's rotor bar. Okay. And the material is a HRS material, heat resistant steel material, and its diameter is around 180 mm. So initially what happened is, this is from HA, Hindustan Aeronautics Limited, and this component was initially manufactured in France, and it has been like imported here. So Indian government wants to do some indigenization on this particular part. So what happened is, this particular material is not at all available. We have to do a reverse engineering basically. After that, like not only for the geometry, for the material also. We have to find out what material they are already using. That also we are not sure. So the case happened here is, they had a very huge amount of MOQ, minimum order quantity. That is not feasible for us. So we have to go for indigenization. in that case only this part came to us. So initially when it came, we did the reverse engineering of the component, and then material wise we found out like it is a heat resistant steel, but heat resistant steel is not a 3D printable item at that particular point of time. And even now, Wipro 3D only moves the parameter for the heat resistant steel. No other 3D printing service provider does this. And one of the critical case here is any part that needs to get into a this kind of defense related application, it has to clear the SEMILAC certification. SEMILAC is another DRDO agency. That people, what they will do is like whatever the part it comes to them, they will only qualify the part. Okay. But at this particular point of time, there is no qualification available for 3D printed components. So SEMILAC, HAL, Wipro 3D, we all three sat together and created a new certification itself. So that would test the particular process of testing the 3D printed component. Okay. That means whenever we print this component, we will be printing some coupons along with that. Rather than destroying this component, we can test the coupons which is along with it and get it qualified. So that's how it happens. And recently we have acquired around the production order for this particular component, which utilizes one particular machine, M290 machine, for 3 years time period. For 3 years time period, it keeps on running for this part alone. So that is a huge order that we have received as of now. And this one is a
Cost of one component.
exactly sure. Lakhs only.
Less than 10 minutes to make the
It's not like less than, most probably like equivalent to heat resistance. Same. Because this material has to be atomized. This material is not available in the market, so we have to go for atomization of this material, and how to manufacturing also has to take place. No, they were not at all clear with the manufacturing technique because this was earlier done in France. And we are now, like when the component comes to us, like we are developing the process. And this one is a GSAT satellites Northwest Fleet Cluster. So this component is basically used for sending the radio signals. And this is the first ever component which went to space from India. That means which, there is a 3D printed component which went to space. First ever 3D printed component that went to space. That is printed by Wipro. And we have done a lot of DFAM uses. I will explain you in some time. And this is a LOX LH2 exhaust casing, and this comes in a rocket component, and it uses Inconel 718 material, and this is also flight certified. And there is a MINS cluster. This is a cluster component which is used for connecting the other components over it. So it will act as a chassis kind of a setup. And 3 burner impeller. This is made in ALS energy material, and this is also flight certified, and we have production. We'll be getting some production order in this. And this is for aerospace sector. Here you can see this gimbal mounted camera housing. This is being used in a helicopter only, and there are like too many number of components. Yesterday we have seen about the part consolidation. So there are too many number of components. They have finally restricted to some 4 components here. And other things are like impellers, inlet body, inner ring again, outlet body. So there are some rocket components being used. So now we have to understand very clearly like why we have to do the additive manufacturing. It is not that every time we tell our customers also we are not going to do it for all the parts. Not all the parts are suitable for additive manufacturing. We have to choose the part which actually requires additive manufacturing because the cost of additive manufacturing is higher when compared to the conventional technique. So we have to choose wisely on that case. First thing is customization. So customization, I told you about that tooth aligners and implants. So whenever there is a high amount of customization requirement is there, then we have to do. Weight reduction imperatives. In the aerospace sector, they will ask for components which is having very less weight, and in that cases we have to implement topology optimization to reduce the weight. So those cases we implement. Optimize the post processing, like the process of the component manufacturing process is very huge. If you want to optimize it, then we can go for AM. Improve functional performance. In the GZ19 satellite, GZ19 satellites component, which I showed you. So this one, initially it had around 12 components, and these 12 components are welded together. So what happens is that whenever you are making a welding, this is used for radio signals transmission purpose. Now when you are having a welding, the performance of the radio signal reduces. So if you want to improvise some functional performance, then you have to go for additive manufacturing. Then superior topology and complex geometry is possible, that you are already aware. And response time and design to realism. If we are having something in our mind, immediately you can get it printed. You know, what is the manufacturing time? I mean, the printing time is saving. Apart from that, no other extra time is there. Cost effective iterations. When the new design is getting generated, that times the number of iterations that we are going to do, the cost that is going to be involved in those iterations are going to be lesser. Toolless production, injection molding requires a tool. When we go for machining also, we have to choose which tools we have to use, what type of milling tool or what type of cutting tools we have to use. So those things we have to choose, we have to procure, all these things will be there. But here there is no tool, right? So toolless production is possible. And better mechanical properties. When compared to casting, we get a better mechanical properties. And monolith structure is like part consolidation. We can do part consolidation with this. Supply chain issue. I told you about the Indian component coming from France. They are having a supply chain issue. So those places we can go for that. And again, that is again like a out of production part also. So they want like too many number of MOQ, then we can go for it. Maintenance, repair and overhaul. Recently we have seen a very great requirements to the oil and natural gas refineries, where they have to regularly do some maintenance. And those components, it is not a big value production component. It might be required like in some 1 or 2 components per year. That would be the requirement. In that kind of cases, we have to go for A. Material workability issue, faster design iteration, flexible production. So if I am printing one component now, the next component, the next design can be different. It's not that you have to run the same component again and again, right? And even when you go for a production setup, they align the machines in such a way that the production process is very easy. So those things are not required here. So coming to the space sector, this was the initial design. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So these 12 components are getting welded together, which has been converted into this particular design. Here, you can see a lot of defam being done. Like, if I am going to just club all these things together, it might require too much of support structures. So what they have done is this has been printed in an inverted way. Okay, not in this manner, in the inverted way it is printed. So on that case, these places you can see, they printed like designed in such a way that there is no support structure which is required. And again these places, this curve is created in such a way that there is no support required. And the connectivity of between these places, it is created as a lattice. So supports are not required, it is a self-supporting structure.
Taking 4 pieces and
Yes, it is printed as a whole, like in a single piece. So the volume is 250 to 5319. So it can be printed in a M290 machine itself. And initially like 12 parts are there, that has been converted into one single component. That was the main advantage here. and still it is in use. Cluster, there is 2 into book. So performance wise also it is improved. Like since there is no welding related issue, the performance also gets improved. ALSI convention. In the case of aviation sector, we have this inner ring component, and we have discussed a lot about it. But actually, what we will do here is this is not printed as it is. This is not the part which is in the as printed condition. We do machining, we provide some stock material over it, and we remove the material from that. Okay? There is a machine part you can consider. We bring it into some net, near net shape. After that, we do the machine. So the different sector, we have this gimbal mounted camera housing component, and this component is printed in the M400 machine. And the size you can consider is around 370 cross 356 mm. Such a big component which is printed in this machine. PO2 part is only 30 days. Very less. Usually it will take around like 6 months to 1 year in a regular production kind of a thing. So, but here it is not that case. And this anti-icing article, here it is not a one single component, like 3 different components are there. One is these blades. These blades are made up of Ti-64. And the center part is made up of inconel 718, and the outer ring is a conventional made one. So this is being used in the aircraft in the front of it, so that icing kind of issues it will be reducing. So you can see the diameter of that overall thing is 1 meter that we can't able to print. That's why we go for printing the things in a separate way to get it assembled. Critical part, because if at all you are trying to print it, you will get the support structures at any place. Design wise, we can't able to make any change because this is the best performing design. Okay. The pump is going to perform better with this particular design only. So design wise, we can't able to make a change, but we have to come up with the orientation in such a way that there is no supports, or even if supports are there, it is easy to remove. That's why we have done this particular component. It's again like ALS 10 mg component only, and the diameter is around 130 mm and the height is around 87 mm. The automotive sector, here this is a component from IIT Bombay, Supra team. They have initially had a component design of this one. They did a topology optimization and they identified which are the places that don't require a material, and they come up with this particular design, and they were able to reduce the weight near to 50%. And not only that, they have changed the material also. So initially it was in stainless steel, and now it is in titanium. Even because of that also the material reduction happens. The density is less. So because of that also the weight reduction has happened. So, like in the automotive sectors also, when it comes to the racing industries, they try to implement this.
Modification of the customer is a 248 grams discount.
Yes. This is 479 gram, the initial component. That has been converted into 248 grams.
Retain the same holes, etc.
Yes, whatever the yesterday we have seen the component, right? The functional basis we have to keep it as is. We can't change the functional basis. It is same. Only the material wherever if it is not required, those pieces we have to move.
Inclined portion, there are 2 holes are there.
Yes, this is an extra thing. This one, right?
There is extra.
This is an extra thing that they have brought it into the design.
One more is there. You see the first part.
Yes.
Inclined portion, 2 holes are there.
Yes, this one you can consider. Actually, this is the orientation.
Upper 2 holes. In the first figure.
This one?
Right side.
This one.
Yes, left to.
Okay, this
What
one.
they are not observing.
Maybe they might have not required this one and changed to this one. So they wanted to make a design change also. Okay, they wanted to improvise their design as well as they wanted to do the topology. Yes, yes. So this is an example on oil and natural gas industry. This is a spray nozzle. So initially it had around like 10 components that have been integrated into one single component. The nozzle complete system is 3D printed. Now even recently, like we are not added here, the PSLV stage 4 combustion chamber, right? The engine, complete engine, we are 3D printing. The complete engine, we are 3D printing, and then the nozzle system also. So that it has got a conformal cooling channels inside of it. Okay, so the cryogenic fuel which is being used, that will act as a coolant for the engine, and as well as the injector is being created as a one single system, right? Now the assembly times are very less. There is a component in the nuclear reactor, it's a fuel rod installation thing, and they wanted a telescopic setup. So for that case, they wanted one component on having a length of 400 mm. And the main problem with this component is the thickness is 1 mm. So with the 1 mm thickness component for a 400 mm length, it is very critical to do. But we have done this. This is a proof of concept part. It is not like a regular production kind of thing. They wanted to try it out. It worked out actually. But further, we did not get any future orders of this component. Might be like it might have not worked out for them also.
Indian or
Indian. And this one is a regenerator component. Here, from the design aspect itself, we can create the porosity. Okay. The same porosity we can maintain in the component. Like rather, porosity comes as a defect, we are generating the porosity in the design and we are building it. And 67% of porosity is very critical that is being achieved here. And you can see that the inner diameter is around 72 mm and the outer diameter is around 108 mm and the height is 48 mm. And this is also again a proof of concept part of it. And there is a case study on healthcare industry. The GE Healthcare wanted to try out one component. This component is being used in a nursing station. Like the nurses used to carry the kids, a structure of a kid. On that case, they have implemented. If they wanted to carry, like the weight of the complete structure would be very heavy. So here, the weight reduction has happened from 400 grams to 202 grams. What they have done here is, there are extra clamps which are available. First, they have identified that this is the actual component, the pit manifold used to call, and this is the external clamp which is going to take too much of weight. And this is the functional place that is going to work. And on this, the design is changed in such a way that the clamping portion is coming over that itself. So there is no requirement for all these extra areas. The clamping portion, this particular place is being added to it. That's it. Like you are getting the final part. So we could able to optimize the material as much as possible by making this kind of design changes. And there is a dialysis filter. This currently like under testing only. It's not they are trying out and they are about to receive the result. And this particular case, this material is a SS3160 material, and they wanted to have all these channels in a one single component. You want to make like the complete length of the channel. You can see the channel there is around 4.2 mm, and that is having a length of around 94 mm. So this 94 mm and 4.6, 4.2 mm is a very difficult thing to obtain. That's what like they try to get it done. This one I don't think is required. But let us see some of the global options of AM. There is a quality setting and wall, top and bottom, these three might not be regularly used. But you can go for the infill density, grid, that means infill pattern, and infill overlap percentage. Like mainly
Changing the standard is there, sir. To take that.
if it is a draft part, okay, or using for some just visualization purpose, you can give 10% infill. If it is like little bit of functional part, but it is not going to undergo any kind of load, then 40%. Maximum. So maximum you can go for 80%. That can give you the good strength. Same way, whenever you are changing the material here, automatically the printing temperatures will change. And the build platform temperature will also change. But we need not like look for it since we are already maintaining those temperatures in the material itself. Same way the printing speed, we are maintaining as it is. We are not making any change in this. Retraction, like whenever there is a print head is going from one place to another without printing. So that time the filament should not ooze out from the nozzle. So those times they have to pull the filament out. Okay, so that's what retraction. Cooling, that's a fan, so that needs to be turned on. And support structure, if it is required, we have to generate it. And here is the important thing: build plate addition. Normally, you can give brim if it is a very big part. Okay, then it will take 2 or 3 layers of material. So I'll just show you here also. I will show you here. So first thing I'll show you the skirt. You can get some idea. Skirt is something like just a boundary arrow. You can see the blue color line. So that will be printed as a boundary. But when you are trying to do the brim, it will create one layer thickness of material on the bottom. Only one layer. So one layer of thickness. Yeah, it will be easy to remove. For small parts, it is okay. But when you are going for big parts, which is going to run for some 3 or 4 days or 10 days, something like that, then you have to go for wrap. Because it makes sure it is completely fitted to the build platform. Otherwise, it will easily come out of the part and print failure will happen. So here you can see it is having like 3 or 4 layers of material. After that only the part will be printed. But for this part, I will go for brim itself. So I am going to save this file. Button, keychain and everything. Then, now we will go to the login of that machine. So the machine, you can see that IP address, same IP address anyhow, I can do it again, 192.168.12.45. So that is available in the machine. And once we log in, now we can upload the file here. ATAL keychain.
But in the mission, you need to download.
No, yes, it will automatically download.
Through cloud, like.
Through cloud, yes. It's a IoT platform. So the file has come here, ATAL keychain, and here you can give it for print, load and print. This will start a new print job. Please check the print rate. So we have to check whether it is clean so that it will start a print.
Doing that, we can.
Yeah, that's it. Here itself we can do everything. We have to make sure. So that's why in future there's a chance of coming up with a print form. There will be hundreds or thousands of printers in a place. The user need not be in the location. So he'll be in somewhere in the world.
Just like in a virtual lab is there.
Yes, exactly. There will be one technician who will regularly clean the machine and make sure the filament is available in the machine. That's it. So they can operate it from the browser itself.
One point I will add to realize me, but before dating, simple Venkateshwara freedom.
Yes, sir.
Get prepared at too much ready, and all of these guys monitored from the TD.
So you can see this target temperature is 60 and
Actually, one.
No, sir.
no, this TL. ABS only 110 will keep. And it has reached almost 60. Now this target is, extruder limit target is 210. It is actually raising now. So once it is raised, then only the next action will start. Here itself, the camera, through the camera you can monitor it. So we have limited some of the functions of this, like there is a terminal option also which is available. Through that, we can send some commands in between the frame. That is possible, but we have blocked it currently. Like many other options are also there. Like AI option is also there.
We can't control it.
It's not. We can control. Like we can pass the print. Those things we can do, but not like sending the G codes in between.
So it's a power failure, it's possible to relate to
No, sir. We are like not activated that option. The reason is if power failure is happening, once the temperature everything goes down, it will not have that capacity to hold the part to it. Okay. So when you are trying to start it again, the print failure will happen. So the better thing is to not to use that kind of option.
Is there any printer that is having the option?
Yes, many printers are having that option, but even I have a printer which is having that option. But when I try to do it, so what happens really is, if a print is happening, in between it stops, the extruder will be kept on a position over the build itself. Okay, because of this heat, the part will be damaged. Now, this damage we can't do anything with that. So, better option is always have a UPS which is powering it. So, we don't require a resume option itself. Now the X and Y is done, Z is coming. And you can see the notifications. Printer started, medic seating, medic seating.
First ever during the time, first ever.
49 minutes is here. Actually, this will calculate all the other timings also. Like,
Actually, it's like.
this will be calculating only the printing time. The other times will not be calculated. All these things.
Actually, we plan the slicing time plus the machine movement
Machine movement time. Everything is getting calculated. Now, 3-point bed leveling is happening. Every time it will do. Because here we have given it. Here printer machine setting. There is a start G code, right? Yeah. Here you can see 3-point bed leveling. G34 we have here. That means it is going to be bed leveling.
Don't want that one. Include that one in setting up caption.
The initial stage.
Right.
So paper பார்த்தீங்கன்னா இதெல்லாம் மார்க்கெட் லைன்ஸ் நீங்க எடுத்துக்கங்க. E0 இதெல்லாம் இனிஷியல் டெம்பரேச்சர் த்ரெஷ்ஹோல்ட் ரன் ஆகுது. இந்த M8 இங்க நம்ம G இங்க நம்ம என்ன கொடுத்துருக்கோம் அது மிஷின் தெரிந்த ஸ்டார்ட் இது எங்கே ஸ்டார்ட் ஆகுது பிரிண்டிங் எங்கே ஸ்டார்ட் ஆகுது இங்க அதுவே இதுலயே பார்த்தீங்கன்னா எக்ஸ் ஒய் எக்ஸ்ட்ரூடர் எவ்வளோ மூவ்மெண்ட் இருக்கு அதுவுமே
சார் இது வந்து இது வந்து நிறைய இருக்கு சார். கிளியர் கிளியர் அந்த நீங்க அந்த கிளாஸ் அது என்ன இது வந்து ரெக்ஷன் லிக்விட் நெக்ஸ்ட் லேயர் இது வந்து கிளியர் இது வந்து இதெல்லாம் வந்து
next one on then I do modeling on printed. Next, tooling fixtures. Many of the industry they use fixtures. So those fixtures can be made in A because they have a requirement of 1 or 2 numbers. Those things we can get it done with. And one of the case study here is an automotive company is using this particular fixture for their wheel alignment purpose. And in the recent days, if you go to Hyundai also, like you can see, a lot of fixtures is getting done in 3D. And this joysticks shoot that's like Google has shown. They do it in SLS and DLP technologies. Rocket engines are getting done in LPBA technology. And implants are getting done. You can see this kind of lattice structure being done in like implants. Any idea like why we have to do that? It is bone not an implant. Like even on the first day I have brought one part. Remember like reason for making that is positive integration will take place. The bone will start to grow inside the implant. So that the strength of the implant also will be higher. That's why no, it's not biodegradable. It's titanium. Like most of the times we do titanium. Like if they want like a lesser cost, they will go for stainless steel. But they might feel that weight difference. If it is titanium, they might feel it like as their body itself. But if it is stainless steel, they will weight. And this one also we have seen the bridge that is built using the 3D printer, DED technology. DED technology. So there is a robot you can see that has built the bridge. And in medical industry itself, O2 vein, so it's like simple clip kind of a thing. It helps the patients to breathe better. And this is a radio waves kind of an antenna kind of a component that also is getting 3D printed. And this for automotive company. So there are like different innovations, like different industries are implementing the manufacturing. So from whether it's an industry vertical, material, technology and value driver, everywhere there is a rise using 3D printing. And in India, like we have also seen the buildings are getting 3D printed, and this defense equipment, like whenever we see any new technological innovation, the first person to implement that is defense. They only will do it. So same here also, they try to like implement some. This is I think a new gun which is developed by defense sector. So these kind of handles, right? Those things they can able to get it done through 3D print. So if it is like broken or something like that, immediately they will 3D print and then start using it. And there is a dashboard kind of part for tank, and even like aerospace sector also, like in flights also they use this kind of a dashboard setup. So this is also getting 3D printed, and they require very small volume of these components. And gifting industry, you can see this the fingerprint is getting engraved, not like engraved, in the design itself they are bringing it into the part. And this is used as the button for this cuff button, as a cuff button they use it. Okay. And this is becoming like a gifting industry. And this one we have seen. In the latest, we have this particular machine called NXG 800 from SLM Solutions, and that has got a volume of 800 cross 800 and height to be 1500. So that much of the component we can able to do. But again, that is again a restriction. More than that, you can't. The speed reading machines, through that they have done this particular component. And new innovations like extruder. Currently it is giving one particular size of extrusion, right? It can able to give different size of extrusion. Currently it is 0.4 mm. It is a static nozzle. So there can be innovations in the dynamic nozzle also. And omnidirectionality. So when you would have seen this particular technique in the construction 3D printers. When there is a movement from right to left, if that's like a 90-degree turn which is going to do, it is the head is also going to rotate on one more direction. So you will get a better finish. Elastomer materials are taking too much of market nowadays because these gaskets and sealings. So these kind of components are also getting 3D printed. Recently we had a requirement from Jabalpur Army, they wanted these kind of ceilings to be 3D printed because they are planning to purchase a machine, or that they have given their parts and they printed a similar kind of ceilings in our printer. So that is a feasible solution. And newer metals, you see this, you can just go through these metals. Aluminum metal, steel, copper, chrome, titanium, nickel alloys, copper alloys. New metals are regularly coming up in the market. And automation. This is what I was also telling you about AI. Since we have a camera, that's an option that we can install one AI model into it, and it can detect if there is a failure that is happening. Immediately the system itself will stop the print. And automation in the design. So design wise, if you tell the software, like this is what my requirement, boundary condition, as like topology optimization, but in the field of CFD. In the field of CFD, what they do is they try to optimize the design in such a way that the better cooling is happening. And shape memory polymers. This is also gaining too much of interest in the areas. And we also have one type of shape memory polymer in the PPU range itself, which can able to change the color, that means the part is printed. Okay, if you give heat, it will change to some other color. Normally it might be in orange, it will change to white or red. The properties, mechanical properties remain same, and that is material that I told is like not a shape, it is based upon a color changing polymer. Shape memory polymers are also possible to be done.
Actually, a few years back, they have done this in 4050.
Correct. Sir also was telling the same story.
Layer, we first one layer they will add it. So, posted one video they using hydrophone. After observing the water, it has become some
other shape.
Shape.
Actually, new innovations are really coming up, and the reason this printer, why it has been built is, it should be a research-based printer. That's what our major aim is, and it should be an industrial use printer. So recently we have given one machine to Royal Enfield for their R&D purpose. They print their components in this machine and do it. And what difference that we can see from this machine to the other machines is, we have not come across any machine even from our country to this level of accuracy. If there are some machines from other countries like Ultimaker, Markforged, and Makerboard, okay, so these kind of machines you can get it compared, but it is not completely open architecture. If you are purchasing a material from Markforged, the material you have to only purchase from them. That material only will be used in your machine. No other materials cannot be used. And because one more thing is, Chinese machines can do an open architecture, but the problem that even I face, I have a Chinese machine, I will not get the parts very easily. So what Wipro 3D provides is, we make sure, if you are a customer, like we will come and provide all the support and make sure your machine is running all the time. Your running time, we are making sure like it's running for the as much of time as possible. Any particular doubts into this? Like we have to discuss anything? So now let us move into the DLP, because we will use the time for DLP. That's what I was planning. That's why I was planning this session in the afternoon. I just kept it here and we'll practice the DLP. feedback can I take it now or afternoon? I think the reason is like will these people like who are available here will be there.
Yesterday there are many people that were not.
I will keep it. What I will do is I will share you the link. Okay, I will keep it open. You can ask other participants who are not there. They give tomorrow. First we will see the machine, then we will come to the software. Build platform that you are seeing.
Sir.
So there is an aluminum build platform.
Sir. Sir.
Yes. And here is actually the technique is very simple. It will take like only 10 minutes to just learn. Not that much complicated. Digital light processing. So there is a VAT tank. So here we have a FEP sheet. There is a consumable like we have to regularly change when the transparency reduces. Okay. And here only we are going to pour the raw material and fit it inside. And this is a LCD screen. We have to be very careful with this LCD screen. If any small damage happens, we have to completely replace the LCD screen. It's like our mobile screen only. Any small damage, it's not going to work completely. And here we have the user interface.
Lights are sung.
Yes, actually the LCD screen will act as a masking only. Okay. So wherever the black color, like it works as a monochrome, black and white. So wherever black is there, it is not going to send any light. Okay, wherever white color portion is there, it is going to send the light. I'll just show you one thing of it. And there is going to be one UV light array on the underneath the LCD screen. So usually in our normal screen, normal monitor, what happens is we will have a backlight. Okay, and there will be a LCD screen like this. So based upon the this particular light, based upon the LCD screen, the backlight is going to provide the brightness. Here, rather than the backlight, we are going to use a UV light. So the UV light is going to provide the some source to get the material solidified. And here is for just testing purpose. We are not going to regularly use it. Here we will be using this one only as a regular activity. The reason for that is to do the build plate leveling. Okay. So the leveling happens by first we have to add this one. Tissues. There is a IPA solution, isopropyl alcohol, for cleaning the machine and cleaning the part. For those purposes, we will use this one.
இன்னும் ஆகுதுல்ல இன்ஃபில்டர் ஒன்றும் ஆகுது.
இது ஒன்று நார்மல் ஐபிஎல் தான்.
గ్లోవ్స్ ఎత్తున్నాను ఆకాష్ గ్లోవ్స్ ఎత్తున్నాను గ్లోవ్స్ ఎత్తనా ఉంటుంది
நான் ஒரு 10 பாயிண்ட் வந்து
மாஸ்க் இருந்தால் போதும்.
Mask 20. Yes, you can just place this by using this screws as the 4 screws as a reference. And there is a hollow place here. You can see these places. Over there only it is going to fit. Okay, let us do the calibration first, then we will go. For that, we have to like fix this one, and we will like just tighten this one, but we will loosen this one because we have to make sure this flatness and this flatness are same. Okay, and so you have to make sure it is completely moving. Then you can come to the floor. If you are keeping it tight, then it might damage the LCD. So make sure it is completely free.
a little bit plane must
Yes.
that will help for absolute flatness.
Yes, absolute flatness. So now in this position we have to like tight it. It's better to keep one small paper underneath it and then tight, so it will give some small clearance. If you have, do you have a A4 sheet, sir?
சில இந்த ஃபைலில் இருக்கும் பாருங்க சார், ஃபைலில் அந்த ஷெட்யூலில் இருக்கும் பாருங்க சார். இங்கே இருக்க வாங்க, இப்போ அந்த ஷெட்யூலில் இருக்கும் அது.
Now you can type. Don't touch because the resin will be there. That's why I.
So if you gloves, வாங்கிருக்கு 10 gloves purchase 13 gloves.
So now we can go to top. this is only work that is available, like the calibration of the build platform. Apart from that, there is no other moving parts or anything. It was initially SLA technology, from there only it was invented, and it is not like one person invented. But SLA is invented by one single person. This was the first ever technology actually. With laser, that was the first ever technology.
Only UV rays is only generated.
Yes. So like this it will come. So each layer, it will be showing some image like this, and black and white, like this kind of. I'm telling you, this screen will be having this kind of image. Okay. So wherever the white color portion is there, that place only the UV light will come. Okay. And that white color, white color portion will be solidified. So I think this is done. Like when we upload the file, it will come like this, and we give start print, it will come. And again, here also we have the IoT option. You have to go here and search for the Wi-Fi. Let it connect in the meantime. Now we have to pour the raw material. So raw material comes in this form only, like a liquid, and there is a solid white standard resin. Here also you can see there is no proper material name. Okay. So we can we can see some of the parameters here, like normal exposure time 2 to 4 seconds, RCB LCD. If there is a monochrome LCD, so we have to maintain it at 2 to 4 seconds of print parameter. And bottom exposure time is the first initial layers. That means we can set how many initial layers it is, like 4 or 5 initial layers. For that layers alone, we can give 10 to 60 seconds, so that it will be stick stronger to the build platform. Then bottom layers is 5. 5 number of bottom layers. For this 5 numbers, a maximum of 60 seconds we can keep. And for the other layers, we have to give 4 seconds.
We go with the printing settings.
Yeah, printing settings there we have to give this. Only these parameters only we are going to give. But whereas in FFF, too many number of parameters are there. So you have to make sure you are, like, do you want to try this by yourself?
So you can
Maybe, so wear gloves. After.
first.
Okay, otherwise I'll keep it here. Any one of you can try once we finish the slicing. So here, and there are some G codes for the starting layer and after layer also. Those things we have to make sure. I'm saving it. Now I will activate the sunloop standard material. So here we have to activate it. Then I can go for the jobs. So the jobs I have to upload this file. Right, successfully open the folder, yes. I'll open this folder there. Add a new job. Choose this file and uploading this file. Sunblue standard material I am choosing. And advanced options are not required. You can submit. Yes, zip file. Actually, the zip file is nothing but I will show you. It is nothing but number of images. That means for each layer, one image will be there, and a G code. That's it. Image all of this. And run G code. So first this will be taking this G code file, and the G code file has got that image number. So it will tell like first open this image, show it for some time, and close it. Then again, second image, open it, show it for some time, close it. That's what it is written in the G code. So the G code is the file which is going to run it on the system. This images is going to be acting as an accessory for the main G code.
And you say after it's as a zip
This all together is saved as a zip file, and that zip file we are going to upload it into the jobs.
automatically it's saved as a zip only.
No,
So if you want to have lots of options, so if you use pen type, so this case, pen type option is there.
yeah, we can do. We have the option. But we regularly don't do it even in office also, because everything is network connected. So here we have different options. Not only is it CWS, Cheeto box file format. So all these file formats are there, like, but we use not STL. STL only is converted into the. Actually, we have the option of uploading the STL, and the slicing can happen inside the IoT platform itself. Inside the platform also the slicing can happen. But we have more options in the slicing software rather than in this one.
The final file will be zip file.
The final file will be zip file, and that is a combination of both G code and the images.
So in the case of support material, I will print it with the same density.
Same density. Same, but only the design of the support is getting changed, and the tip of the support is right. That one we are going to make a change. You can have a look at here. It is smaller at the end. So it is easy to break at that particular point. So now we have the job here. We have uploaded the job. We can just hit start. But before that, we will fill the material and then start. This file is available in the machine also now. There also we can give the start.
So we
So you have a maximum level here. Max level. You need not pour that much, but still, this is a small part only, no? So you can pour some off of it, off of the max level. That would be enough.
What are the compositions of
Don't waste.
This will be available in the website, sir. But again, it's not a standardized.
சரி ஒன்றும் ஆகாது ஒன்றும் பயப்படாதீங்க.
கேமராமேன் சொல்ல
கேமரா சொல்லி வேர்ல்டே ஓடிட்டு இருக்கு.
சார் முடிஞ்சிடுச்சு ஃபினிஷ்டா
Finishes.
Finished.
ஓகே
Anybody else has prepared any files, sir? For that, for the FFF? If you have any file, you can give the print.
ஃபைல் எல்லாம் வச்சிருக்கீங்க
Half of the max level.
சரி பார்த்துட்டு போயிடலாம்
Create a file in the same pattern only. Instead of ATAL FDP, we will print our name.
You want, you can create.
Separately have to print.
Separately you have to create a file.
We don't know how to create.
Okay.
We are not familiar with
Close it.
சேம் கேஸ் அங்கேயே இருந்துருக்காங்க
இப்போ அதான் சார் பண்றோம். அதே டிசைன் தான் இருக்கும்.
We can check that this is also one of the experiments.
I think you can operate. So that's houses. You can go to plates. Here you can see ATAL, first one. The file that we uploaded there, it is available here. Now you can give start print.
Wait for
No need. Sir.
I think all three is printing also.
All three will be printing. Now the platform is going to the bottommost position.
What actually now starting is bottom layer.
First layer. Bottommost layer. ஃபர்ஸ்ட் லேயர் பாட்டம் லேயருக்கு நம்ம 60 செகண்ட்ஸ் கியூரிங் டைம்
ஓகே ஓகே
நல்ல ஸ்டிக்கா இருக்கும். ஒயிட் கலர். ஆமா ஒயிட் கலர். டிஷ்யூல தொடச்சு இது ப்ளீஸ் ஐபி தான்.
Time consumption.
அது ஐபி தான்.
One
அதுல அந்த நீங்க
க்ளவுஸ் போட்டுருக்கீங்க சொன்னாரு க்ளவுஸ் போட்டுருக்கீங்க
கொரோனா பீரியட்ல இப்படி தான்
க்ளவுஸ் போடுறீங்களா தைரியமா பண்ணலாம்.
இப்படி தானே போட்டிருந்தோம் மூக்கை விட்டுட்டு கீழே போட்டு வாய்க்கு போட்டுருந்தோம்
அது டிஷ்யூ
சார் டிஷ்யூ பேப்பர் வாக்கிங்க
Tissue paper is here.
You can take it.
That's it's a very simple process. Only work is there. We are going to do the slicing.
Exercises actually.
So you can try, sir. Now I have already shared the files.
Yes, sir, we will try.
You can try and give something for printing. Horse idhula pannalam. Idhula pannalam. Neenga print idhula.
என்னோடது கொன்னுடும்
பட் நாங்கள்
சார் இதுல போடலாம்
போடலாம் ரெண்டுமே ஒரே இதுல.
இந்த டைம் தான் நினைக்கிறேன்
ಈಗ ಲೈಟ್ பண்ணலாம் ಸರ್
மார்னிங்
ಅದು ಮಾತ್ರ ಏನು ಸ್ಟಿಕ್ ಆನ್ ಅದು ಮಾತ್ರ ಸ್ಟಿಕ್ ಆನ್ ಆಗುತ್ತೆ
முடிஞ்ச வரைக்கும் இதுல பிளாட்ஃபார்ம் ஃபுல்லா ஃபில் பண்ணிட்டு நம்ம
டைம்
but chances of failure is also higher. The reason is until the part is going to come to the topmost position, we don't know when it is going, whether the part is properly sticked or not.
ஓகே
So until that time, we have to wait for some time and see it is coming properly or not.
What is that liquid name, sir?
Sunblue is the brand name.
It is brand name. Resin only, sir. It is resin. Resin அவ்வளவுதான். That is.
So the platform specifically we have to do some like we have to apply preheat like that.
Nothing. You can just clean the platform and then add.
Now, working principle is concerned, wherever this white the sun, the light will.
Actually, the reason why we have given like this is we can able to see that layer, first layer. The first bottom layers alone, it will come for some height. We can see that whether it is created or not. We can see that one.
Yes, sir.
This portion alone, it is printed.
Yes.
இல்ல ஹீட் ஆகுதுல
Heat is no heat.
No heating, sir. Only UV rays.
Only UV light. So it should not be exposed to sunlight also. If it is exposed, that's it. All the raw material is gone. It's wasted.
Central.
Only light.
பாஸ் ஆகும் சார். இப்போ இது கீழே போகுதுங்களா, ஒரு லேயர் கேப் அந்த 50 மைக்ரான் கேப் இருக்கு. அந்த 50 மைக்ரான் கேப்ல கீழே இருந்து அந்த லைட் வந்து பாஸ் ஆகுது. எந்த இடத்துல அந்த ப்ரொஃபைல் இருக்கோ அங்க அந்த ஒயிட் கலர் இருக்கு பாத்தீங்களா, அந்த இடத்துல மட்டும்தான் லைட் பாஸ் ஆகும். அப்போ அந்த இடம் மட்டும் சாலிட் ஆயிடும். சாலிட் அந்த பிளேட்டோட ஒட்டிடுது. அப்படியே நெக்ஸ்ட் லேயர்
Plate 50 microns க்கு தான் உள்ள difference.
50 micron is the difference between the sheet and the plate.
அந்த ட்ரே இருக்குது அது அந்த வாழையோட அவ்வளோ திக்னஸ் தான் பண்ண முடியும்.
அப்படி இல்லை சார். நீங்க எக்ஸ்ட்ரா இப்போ நீங்க பாஸ் பண்ணிட்டு இன்னும் கூட ஊத்திக்கலாம், காலி ஆயிடுச்சுன்னா. நீங்க ஃபுல் 300
நம்ம பண்ணணும்.
ஆமாம் பண்ணலாம். நீங்க அப்படியே பாஸ் பண்ணிட்டு இன்னும் காலி ஆயிடுச்சு, if the material is over then we can again fill some material.
After each layer will it come again to top also?
First actually we have given like
16 seconds.
5 number of bottom layers, right? So those 5 numbers of bottom layer alone it will come to higher distance, so that we can visualize and see whether it is sticked or not. Other layers, the normal layers, it will just go 2 or 3 mm high and it will continue the printing. Now we have those two things. We'll just see, have a look at it.
Yes, sir. Until.
So most of the times we will not do it. The reason is we will not be having too many big pieces in a college level, like, but in an industry level, like if you are having big components and using too much of IPA, we have that much of IPA. If I completely fill it, it's overdone. It is wasted. So better is you can clean that part with the spray also. So that will consume less amount of IPA. Otherwise, you have to put it inside and so here we have to set the time. How much time we have to run it, and once you run it, there is a magnetic stirrer that will rotate. Liquid should be there. So it will rotate and it will keep on be like a washing machine. It will be keep on be washing the component. So all the excess resin over the part will be removed, and it goes with the IPA. So once washing is completed, we have to remove the support structures by manually. So using the pliers, we have to remove all the support structures. So once that is done, we have to keep the component inside this, and this is a UV light.
And what's the time we have to keep it?
That is just for washing those. Like if it is a small component, you can keep it for some 2 minutes, 3 minutes. That is enough.
Okay. For this one, sir?
For this one, you can keep it for some. You can see.
How to check that?
Okay, I'll check. I'll tell you one logic. If it is taking 60 seconds to completely cure, here also you can keep similar kind of time. Maximum 5 minutes or 10 minutes you can keep, so that the complete part will be cured. If you are making like too much of solid component, like a complete solid component, very bigger one, then you can increase the time. Okay. So once this is done, like here also you can set the time and click it. UV light will be on, and it will start curing that.
Here also UV light, here also
UV light. But here we are keeping it for a longer period. There it is like 4 or 5 seconds for each layer. That's it.
Curing and temperature maintaining.
No, nothing like that.
Just
Nothing.
exposed
Just
to the-
exposed to the UV light. So that is also possible, but that is like they use a different formulation of resin. For those resins only we have to keep the heating. Not for all the, for standard resins it will work. For tough resin, rigid resin, those things only we have to switch on the heating also.
Sir, will it applicable for thermoset resin?
Plus we are not using any UV light. ஐபி சொல்யூஷன் அது இப்போ நீங்கள் இது ஃபுல்லாக ஊற்றிட்டீங்கன்னா உங்களுக்கு எல்லாமே வேஸ்டேஜ் ஆகிடும். ஸோ அதனால நம்ம என்ன பண்ணலாம், ஸ்ப்ரே வச்சு நம்ம பண்ணிக்கலாம் சின்ன சின்ன if you are if you are regularly printing, then you can fill complete material and put it inside and then leave it, like washing will be happening. Okay, and one after the another you are having a part. In that case it is fine, but I am doing it once in a while. So on that case I can use the spray itself and manually I can clean it. So IPA will not be wasted.
UV is same capacity, sir. Same capacity UV.
Yes sir, 405 Newton meter wavelength only, same thing. Curing time.
Will it prevent the exposure outside?
Yes, it will prevent.
3 layers. So I think that also we have to define. 4 layers, I think, for this.
So now you can try the in the software.
Also the curing time we give.
So you can take one PC for each of you. Three types of structure. அது வந்து கீழே இருக்க பேசியும் பாதிக்காது. இது ஒன்று முடிச்சு எடுத்தோம்னா அப்படியே வந்து நீங்கள் காலையில் எடுக்கும்போது ரொம்ப கஷ்டமாக இருக்கும் போடலாம். ஈஸியாக
We can vary the thickness, sir.
எஸ் சார்.
We just